About a decade ago, I worked at a large software security company that's publicly traded, and I talked to one of their pen testers about a project that they had just concluded. He showed me their report, and I was looking through the findings, and I was like, "Are you going to report these as CVEs?" And he said, "No, we're not required to. It's under NDA. We're not allowed to talk about these." And it left an impression. Why have these vulnerabilities disclosed to the vendor only when they should be going out to everybody in the industry? I get it. Companies don't want to be seen as vulnerable, particularly if it's in the interests of the public to know that they've got vulnerabilities. Could they be at risk? But on the other hand, if other utilities are suffering from the same vulnerabilities and don't know about them, that's not good. This is a story about an ICS security assessment professional, what he's seen in the field so far, and where there's still room for improvement, such as following the SANS best practices for ICS security. I'm Robert Vamosi. This is Error Code.
I am Don C. Weber. I am a security researcher and penetration tester, security assessment analyst at IOActive. IOActive provides cybersecurity services to a number of industries. The one that I'm more involved in is the industrial control environment, where we do security research, security assessments, and where possible, actual penetration testing into the deployed environments.
So let's unpack what IOActive does. You've probably seen them at Black Hat and at DEF CON. You know, they're the ones that got on stage and talked about the Jeep Cherokee hack in 2015, or the ones who hacked the hotel rooms in Japan, or who hacked traffic signals in smart cities. So I see IOActive as a team of very creative consultants that are brought in often to test different aspects of, say, ICS. So how did Don get involved with IOActive? What's his story? What is his background in ICS?
So my background, I started as a normal cybersecurity professional when I got into IT. After I got out of the United States Marine Corps, I went to college, got a degree in computer science. But I always kind of knew that I wanted to go towards the cybersecurity field. And this is back in the early 2000s. It was before a lot of organizations understood cybersecurity, and even if they did realize that they needed a cybersecurity team, they were pulling from internal. They weren't really hiring anybody for it. But fortunately, I got a job that helped me get some training, some SANS training, and I got my master's degree in cybersecurity. And just moved forward from there. And I did that for a little less than 10 years. But what I did is I knew that, I was a little bit older coming into the technology industry, and I needed to do my own rapid development. And so I started talking to people, asking questions, doing a lot of my own research in the evenings, my own studying, and talking to people and asking for projects. And I just happened to I pestered one person over and over again until they finally gave me a project to do, and I excelled at the project. I stole a lot of code and made it my own and made it do what they needed to do. So it was, so I hacked my way into it. But at the end of the day, what they had done is he worked for an organization that was helping the critical infrastructure, the utilities, back in around the 2010 timeframe. They had what they called smart grid working groups. And the smart grid working groups were a chance for utilities throughout North America and around the world to look at cybersecurity, look at the new technologies that were being put out in place, being put out into the general public.
Back in 2010, in the United States, there was an initiative within the Obama administration to install as many smart meters in homes and businesses as they possibly could. The utilities, in turn, would get a payout from the government. To be fair, this was brand new technology being rolled out very, very quickly. And so there were these security working groups that were trying to secure both the implementation and the design. They're basically flying in the air while building the airplane. And it was in this time period when you saw researchers at Black Hat and DEF CON demonstrating how they could manipulate the data being reported so that it would spell out their names or other words. They also pointed out that they could do more ominous things if they wanted to. They just wanted to sound the alarm that not all smart meters were secure out of the box.
They wanted to understand what they were supposed to do with it, how they're supposed to protect it. What were the hackers? What are the threat actors going to be doing to these publicly accessible devices? And can they actually get into the utilities network and start wreaking havoc? So they needed to understand that. And the person that I had pestered, that I'd mentioned that I'd pestered, he worked for an organization that was doing this research. And when they started needing people to do security assessments for different utilities, they brought me in. And that's how I got into it. So, my first job was actually learning what smart meters were, learning what advanced metering infrastructure was. I had no idea what hardware was. My background was actually in cybersecurity. It was in forensics, incident response. I knew how computer works. I knew how to find things in people and what people did, or what people had done on computer systems and within networks. But I had no idea about this hardware stuff. And so I got a crash course in pulling things apart, doing hardware evaluations, soldering, ended up doing communications between the different components, radio communications, radio analysis, doing research into that. And so that was my introduction into this. Back in those days, I was working for another company, but IOActive, a lot of the research that I was using, that I was looking to help me understand things. A lot of the people that were working for IOActive back then, I was looking at some of their research that was being put out during Black Hat and during DEF CON and some of the other events, and just taking what they were doing and making my own, and using that to progress my skill sets and some of the things that I was doing.
So if I understand correctly, it sounds like Don has seen both sides of the security equation when it comes to smart meters. He saw it from the utility side, what was going on, and he's also seen it from the attacker's point of view, what he could do. How realistic are those smart meter attacks that we hear about?
So, I mean, you probably heard the heavy sigh when somebody changes the display, on a device, and I've actually had to fight that. I actually had to tell people stop doing that. That's not a finding in certain cases. It might be important. You have to remember sometimes where we're at, the isolation, the fact that and that's a big misnomer in our industry. Yeah, yes, there are unencrypted protocols. Yes, there are protocols that don't require authentication. Those things are selected for very specific purposes. I think it's fair to ask whether or not we should be securing those communications, but at the same time, because of latency, because of the need to process information at a certain speed, the personnel that were associated with deploying that, both from the client and from the vendors, they've selected very specific protocols to perform specific functions under very concerning conditions. From the passing of electrical, all of the electrical interference associated with some of those environments, heat and cold and so forth, do have an effect on how these technologies perform.
I'm curious, when we talk about ICS, it covers a lot of territory. It sounds like Don may have been in the power grid area or the energy sector.
That's the interesting thing about in ICS, industrial control systems, and automation systems as well. The components are found throughout multiple industries, multiple sectors. And yes, I cut my teeth on smart meters, on advanced metering infrastructure, those communications and so forth. But those technologies, those concepts, the things that make up hardware, the risks around threat actors gaining access to these devices and these environments, they're similar across all of the sectors. Now, the communications might be slightly different. The risks are going to be different because they've obviously got a different focus, a different output. They're making different widgets. They're pushing water instead of electricity, or they're doing a building automation, or they're doing manufacturing.
True, while specialization is always good, there are similarities between ICS technologies that Don can leverage.
So it's been pretty easy for me to slide back and forth a little bit because the technologies are the same, the implementations are very similar, but also because I'm flexible in my thought process, I realize that I always approach all of these, any new sector with, I let people know that, hey, I've got this background, I know the technologies, I know the communications. I might not know exactly what you're doing, but that's why I need your help to figure out what's going on in your environment. There's a lot of communications, a lot of back and forth, just understanding the situation before we even start delving into security assessments or penetration testing. You have to understand the environment, but usually the technologies are very similar and you can transition pretty easily if you pay attention.
So Don mentioned that he came off a 2-week pen test. What does that process look like? And what are the people typically contracting him to do?
And it's slightly different because many people think about security assessments. They think about penetration testing. That's the first thing that come in their mind. I mean, penetration testing is sexy. You get to exploit things. You get to take advantage of something, gather information. Now you control that device or that service. You can pivot to somewhere else and you can take some advantage of something else. And you get to do very, very interesting things within the environment. Okay. And I've done that in the corporate environments, but ever since I kind of moved into this the ICS environments, the operating technologies, critical infrastructure, and so forth, what I've found is that I do very little of that exploitation, meaning that we're coming back. We have to take a step back. We have to remember the core concepts around cybersecurity, the things that we're trying to do to protect things. We have to evaluate the implementation of those technologies, how the technologies are deployed, how they communicate, and what are the risks to those implementations. And we have to do it in a manner where we're not going to have a negative effect on that environment. We're not going to bring something down. We're not going to stop something. Because especially when we're in production environments, that could lead to a shutdown, which could lead to cascading effects that affect safety within these environments. So when we talk about security, the reason why I use the term security assessments a lot since we've been started talking is because typically when somebody's asked me to do a pen test within these environments, I'm not doing your traditional pen test. I'm doing a security assessment, evaluating the maturity of their countermeasures that they've implemented to understand the what I call implementation issues, okay, or risks that we can understand the how the vulnerabilities, known vulnerabilities, unknown vulnerabilities affect the implementations of the technologies. I very rarely pivot. And the times, and actually we did actually do some pivoting in the last 2 weeks. We were taking advantage of services, the permissions on certain accounts. We were able to replace some services with our own files, which got executed and provided us system on a Windows server. And, that was very exciting. But at the same time, this is a very controlled environment.
Right. A key difference between IT systems and OT systems is that the latter is production sensitive, often life critical. It's not always possible to bring everything down just to test and patch. ICS systems, well, they may have found another way for the testing to get done.
What I found is a lot of the larger utilities, because of the regulations, the NERC regulations, they actually have staging environments where their vendors will come in and build the solution that they're going to deploy within their production environment. In other words, they have a test system. We come in, they've got it all set up, all the data flow, communications. Here's how we're going to implement it out in the field. Please do a penetration test on that. And we're able to do that because it's not connected to it might be connected to some hardware, getting data and so forth, but it's not affecting the actual productions systems or anything like that. So it's because of those lab environments, because they have that requirement, I'm able to do some actual penetration testing and pivoting exploitation within those environments. But that's few and far between. And even in the lab environments, some of these things are so complex, we might not do that pivoting because we don't want to have an effect on, the actual solutions because they're expensive.
When Don talks about doing a security assessment on integrations, is it looking for things that are on by default? What are the things that Don looks for when he does a security assessment?
That's a very interesting question. It's a lot of times when we're and that kind of goes back to that whole security assessment penetration test, the difference between those. Because if you're doing a security assessment, if you're evaluating the implementation of an architecture, you are looking at all of the core concepts around network implementation, the architecture, segmentation, isolation, attack surface, permissions, remote access, and so that's typically how I approach my evaluations, my security assessments. And actually, I found because I do more security assessment type work, I do less penetration, I do less exploitation. Some of those skills from a penetration, from an exploitation standpoint have atrophied a little bit just because I'm not using the common tools and tricks to test the what happens when something actually gets exploited. But yes, we're looking at those implementations and we're trying to understand the risks to the actual environment. And we can talk about all of the different vulnerabilities, the known exploited vulnerabilities, the all of the common weakness enumerations that that affect a system. But in the long run, what I try to focus on is I try to think about how data is coming in and going out, because that is important. Like you can't exploit anything if you can't get it. Yes, we can have a remotely exploitable service, but if you can't get into that environment and send data to that, then how can you exploit it?
Right. Often these are segmented and not connected directly to the internet.
So understanding how people access these areas, I really focus on that. I do look at the attack surface. If there's some way to communicate with a service, I start looking at that. And then I start asking myself, how is that service, how is that data used within a workflow? In other words, I can send data to this one system, okay? And I'm sending it over, leveraging an API. That service gets it. It validates that information is correct. It was what is expected. I expected numbers. I expected numbers within this range. Okay. But when I pass that, when I put that in the database, what does the next service do with that information? Okay. How does that process it? And if the first one didn't check that, didn't check for unexpected inputs, how does it execute on that information? And so typically that's what I'm doing. I'm evaluating how administrators and other end users are accessing the systems, how they deployed on the network, the attack surface, and then the data flow.
So in aggregate, looking back, what would Don say are the most common things that he uncovered from assessment to assessment?
That's an interesting question. There's so many little tidbits, important things that come up from different things. Some of the things that concern me are that those issues around input validation. A lot of people think that, especially integrators, vendors, and integrators that are implementing some of these systems, they tend to feel that the communications are secure, and that they're isolated and they're not well known, okay? Or that when they've implemented some of the security protections, that nobody's going to get data in there. But so they don't test those inputs. They don't validate the data is what they expected. They don't understand how it's going to be used in the workflow. And so, a lot of times, a lot of my findings are interacting with the application API channels, injecting information, and identifying when they're not validating this information. I might not be able to get exploitation down through the workflow, but if they're not checking, I know eventually I'll be able to do it.
Here's a simple idea. Follow the data. See where it's going and where it might have been compromised in the overall process.
So I find a lot of that. And one of my concerns usually about the vendors and the integrators in this area is that they're not sharing those findings that we come up with for those technologies. They might fix it for that one client, but they're not passing that information down through their own development, whether it's sending this back to the product developers, the other integrators that are implementing the same technologies at different locations. Okay, that knowledge stays at that client, that shared client where we're going into. It's not passed on to those other areas. And I've actually gone into other clients with the same technologies and found the same exact vulnerabilities. It's like, hey, well, why didn't you share this information? Why didn't you share this data across your teams? Now, I do know that there are vendors that do that well. I mean, I'm personal friends with people that's their job, is to ensure that information is evaluated, that it's passed on, that the developers get the data, and that their integrators, their teams get that training. But we have so many third-party integrators that might not get that data. Some of these vendors that we're talking about, they're huge, they're international. And it's natural that not all of that information gets out to some of those teams. But that's probably one of my biggest frustrations around the assessments that I'm doing, is that I find something, I fix it in one location, and I just think about how many other locations aren't getting the benefit of that assessment.
I'm wondering if that is a question of maturity. It sounds like even large companies don't pass this information on to others.
A lot of people will think, oh, well, Don, why aren't you creating a CVE for this? Why aren't you notifying the industry about these vulnerabilities? Well, that really depends. It doesn't depend on the maturity of the client. It depends on the maturity of the vendor as well, because typically when we go into these, it's a non-disclosure agreement. We're going in. We're going to talk about specifics around this. We can't disclose specifics around these things. So that naturally kind of forces that stickiness of those findings to that particular client, and sometimes just to that one implementation of that, because sometimes the clients don't even pass it around to other parts of their organization because they don't want that vulnerability information getting out, right? So they're just naturally keeping the OPSEC around that information.
The danger in not reporting is that we keep finding the same flaws.
We've seen this resurgence of cybersecurity professionals looking into these technologies, finding vulnerabilities in the devices, refinding issues around Modbus and other insecure protocols. And this is all, and if you've been going to Black Hat for this long, we talked about this back in the 2010 timeframe. This is what we covered, and what's really interesting to me is seeing some of the publications more recently talking about smart meters and AMI, and going, oh, I wrote that 10 years ago. Right, I wrote that up that issue. I talked about this, and that's great. More power to them. I hope they're getting penetration and helping the 3,500 different utilities within the United States, or within North America, excuse me, improve their implementation. Right, but at the same time, yes, this information has been out there. We've talked about it, and what I find frustrating is when people are finding these vulnerabilities in these products. And I'm glad they're doing the security research around that. They're identifying these issues. They're publishing them. They're giving them to the vendors. They're identifying them so that the people that are implementing these technologies understand the risks. All right, I think that's a great thing. But once again, putting out a vulnerability around Modbus and the lack of authentication and encryption, that's not really a vulnerability. That's just an implementation feature. Now, depending on how you're using that technology, is what is the risk to the implementation that's a concern.
By calling out these issues, I see some vendors perhaps refusing to talk to anyone about the patch or the vulnerability.
When I read some of these new CVEs around vulnerabilities, and I see them calling out these issues, I see them saying the vendor refused to talk to us and patch this vulnerability. I've got a little red mark on my forehead from me smacking my forehead because they're not doing it right. Okay, yes, the vendor should be patching these vulnerabilities. They should be looking into it and figuring out how to address these things. But the first thing to do when you're considering these issues is to look at the architecture, improve the architecture, understand how the technology is being implemented, manage the countermeasures associated with that from the implementation standpoint, improve the architecture, turn the service off. You can't exploit a service if it's not talking on the, not accepting communications across the network or the field bus. Okay. And that is enough. You might not have to patch. And what a lot of people don't realize is the cascading effect that some of these patches that they want to do have. Okay. You patch that device, but that patch means that now you have to update the management software. Updating the management software means you need to update the server. Okay. Updating the server means that you have to update training. You have to update, and sometimes the patches aren't patches for the device. There, the vendor says, "Oh yes, we fixed that in this new version," which requires new wiring and so forth. Okay, and so if you don't understand the cascading effects of some of these recommendations to patch, it's not. While it's okay to say it, it shouldn't be your go-to associated with reducing the risk. What I'd rather people do is rather them talk about the architecture things that you can do if you know a device is vulnerable to a certain thing, can you turn that service off? Mention that. What I'd really like to see a lot of people do, and vulnerability researchers that are publishing these things, showing me your maturity by helping us identify how to see that exploit on the medium, okay, whether it's wireless or whether it's Ethernet or whether it's a field bus. Tell us how to detect that. Give us a snort rule. Give us a string of bytes that are associated with this, so somebody else can write a similar rule to that, so that we can do prevention and we can do detection.
In addition to performing security assessments and pen tests, Don also teaches an ICS security class at SANS, and as part of his training, he discusses the best practices for ICS security.
The SANS ICS team got together, Rob Emily and Tim Conway got together, and they started looking at all of the information that they got, both from their experience out in the field, the information that they were getting from the industry, because SANS does a lot of does a yearly ICS information gathering survey. They do a survey. Okay, and so they started looking at this, and what we started seeing is that there's a lot of different information about how to protect your environments, how to protect your control environments. When you look at 62443, and you look at all of the things that are required to implement a good cybersecurity program, leveraging that framework. Okay, it's great from a risk management standpoint. But at the same time, it can be overwhelming, the number of things that go into a cybersecurity program. I'm a big fan of 62443, but at the same time, asking somebody down at the process level to, gather information and implement all of these different things, especially when we're talking about critical infrastructure people in water, in electricity, in manufacturing, in shipping, their job isn't to be a cybersecurity professionals. They don't want to do anything about it. They actually just want us to a lot of time I've actually been told, why are we doing this? Just tell me what to do. Right. Okay. And so I had come up with my own, as we talked about, I have my own kind of methodology around doing security assessments, quickly getting to identifying risk that can be that can have a quick risk reduction within that environment. In other words, protect that environment as quickly as possible. Okay. And when I first read this, I was like, oh man, they're just stealing everything that I talked about, because basically what they're saying is that, hey, there's 5 things, you need to have a cybersecurity program, but while you're getting that ready, what you really should do is focus on these 5 things, because if you look at these 5 things, you're going to get quick risk reduction, and then you can start moving forward and getting a better, more mature managed solution. Those 5 different controls, I'll just read it in order that they have it. I don't necessarily agree with the prioritization, but I don't think they were given it. So first of all, incident response, ICS incident response, because it's different than within your corporate environment. How you respond to incidents. You talked to Leslie, and I'm sure she told you the differences between it and how important it is to manage that correctly.
In episode 37, I spoke with Leslie Carhart of Dragos about the criticality of incident response in ICS. Namely, you can't always take down the system to analyze an event. So you got to get creative. Nonetheless, incident response is vital to the understanding of what went wrong.
ICS incident response needs to be talked about. Tabletops need to happen. Those playbooks need to be drawn up. The second one, defensible architecture. And you heard me talking about that. The implementation of these things, how we're deploying them, how we're interacting with them is important to understand. So you need to have an understanding around that. ICS network visibility monitoring, meaning we should be listening to what's being exchanged across the wire. Okay. Because the only way that you can have an impact on these environments is if you can get data onto the field bus. Because we're limited to the types of communications and the communications within these areas, it's pretty easy to identify suspicious, malicious network traffic if we know what our baseline is. So we need to get an understanding of the baseline, and then start monitoring for unusual activity. I think that's very, very important. I'm an incident responder at heart. I need all the data I can get to help you understand what's going on. The fourth one is secure remote access. And as I mentioned before, that's one of the things that I mentioned before. How are people interacting with these environments, whether it's coming across the corporate network, whether it's external because they have to get into that from home into the wastewater facility. How do we allow remote access? We need to understand that, look at that, improve that as much as we can. And then finally, a risk-based vulnerability management system. In other words, we need to understand what's in our environment. We need to understand our assets, how they're implemented, and then look at the risks around that implementation so that we can make quick decisions to reduce some of that risk. So I really like the SANS ICS critical controls. They help me kind of explain my approach to a lot of people that aren't familiar with this. But it also helps with that implementation. Like I said, most people just want to know, all right, how do I do this? How do I quickly reduce my risk so that I can keep on my operations? This is a great approach for that.
I'd like to thank Don C. Weber for coming on Error Code and discussing what he does when he performs an ICS security assessment or pen test. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Join us on Discord. Search for Error Code Podcast to join the server, or go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I have more conversations coming up. I'll have conversations about Secure by Design and more about Operation Volt Typhoon. Subscribe today. I don't want you to miss out.